So these are staff researchers with Redwood Energy, and they did a fantastic study of the opportunities to save energy in cooking. I mean, so noteworthy that no less than Amory Lovins corresponded back and forth about the findings and sending over papers. Like this is, I think, an excellent side-by-side example of how much energy is used and can be saved in cooking, which is a peak load in the evening, which is a large power demand in the evening. It's both large in energy and in power. So could you bring up your slides, Rebecca and Nick?
Yes. Let's see. One moment, I'm sorry.
No worries. By the way, I found the results totally startling. I did not expect at all what you guys consistently found. And it's already changed like our design practice. We're doing with Josie's church, we're doing an electrification plan, but also resiliency plan, how to run the church as a place of refuge on batteries. And a lot of what people need in a time of real hardship is food. You know, that's a basic, is having some warm food, ideally, a few times a day. So show us how much energy we can save and how we might be able to, feed more people during times of crisis, as well as just every day, at home. Take it away.
Awesome. Is everyone able to see my screen, right?
Yes.
Just want to make sure I'm not talking to a blank screen.
No, we can see your screen. We can see your little icons at the bottom, but it looks like it's the whole screen other than that. So go for it.
Yeah, sorry about that.
No worries.
Yeah, you got it. Okay. Cool. Well, thanks for that introduction, Sean. Today we're going to be looking at our high efficiency cookware study. I'm Rebecca Hueckel.
And I'm Nick Brandi.
Cool.
And yeah, we're stoked to talk to you guys.
So our outline of what we're going to be going over today. First, we're going to talk about why we did this study and what our goals are, what we used, how we did it, a little bit about our results, and then the human aspect of it all, like how practical each cookware is. And then lastly, we should have a little bit of time for questions, but you can always put them over in the chat box and we'll try and get to them after the presentation.
Yeah, and keep in mind, you have 15 minutes, so probably not a whole lot of question time.
Okay. You should have 1 minute. We timed it. Okay, so our goal, our hope was that this information will help minimize kitchen plug loads. Our goal is to find innovative ways to minimize our overall plug load by focusing on cooking products in the kitchen. And we're doing this to assist the effort for housing to become zero net energy or to just largely decrease our overall demand. These products are best suited for multifamily housing, single family housing, and multi-unit complexes and apartments.
So our approach on this was to get a variety of different types of cooking products and see which ones could minimize our energy the most. And we wanted to take the approach of insulated cookware as to, retain the heat and energy for the food rather to the, surrounding area. So we started with a crock pot, or a slow cooker is also called. And yeah, like I just said, this is a really good insulated product that can retain that heat. And we also tested products like a pressure cooker, and we did 2 pressure cookers on this because we wanted to see if the size would have any relation to the efficiency. So the first one we did was a 2-quart pressure cooker, and the other one was a 5-quart pressure cooker. As for the next one, we did the Sonavo 1500 watt electric resistance cooktop. We figured just your plain electric resistance cooktop would be the most typical type of electric countertop cooking product that most people would have. So we used this as our baseline. We knew it would have the highest energy use out of all of these products, but we just wanted to use it to compare the other products and see how much it truly minimizes the typical energy load. The next product we used was the induction range. This isn't, obviously it's not an insulated cooking device, but it does use less energy. So we also wanted to see how that would fare with the rest of the products. And the last item we used was the air core 8-quart insulated pot, and this is a really cool type of product where it has 2 metal walls and then an open air chamber between the 2 walls within the pot. And how you use it is you heat up whatever you're cooking, your water, your beans, whatever, and the air within the 2 chambers heats up, and once you're at the temperature you need to be, you're able to take off the entire pot and let the residual heat cook. So this is really interesting for us. If we could just not use energy to cook, that's really the end goal. So yeah. So yeah, our testing method was pretty straightforward. It was just cook garbanzo beans. So we soaked dry garbanzo beans for 9 hours and strained them until they were dry, and then just went ahead and cooked them. In doing this, we made sure to keep a consistent volume of a total of 5 cups, which 4 cups of which are water to 1 cup of soaked garbanzo beans. We made sure with our kilowatt meter to record the watts, the kilowatt hours, and the cooking time for our efficiency. And with the variety of different products, we needed sort of different approaches on how we cooked these garbanzo beans. So the induction cooktop was the most, I guess you could say, classical way of cooking garbanzo beans, and that was to just bring the water to a roaring boil. And when the water's boiling, you put the garbanzo beans in and then put a simmer on medium. The electric cooktop needed to be on high for the water to boil, for it to be at the proper temperature to cook the garbanzo beans. And the air core was interesting because you actually had to start with the garbanzo beans in the pot as you're boiling the water. And this is because we want to keep the whole item closed so we could retain the heat. And if we were opening it up and all that, the air chamber would cool down and we would be using more energy than we would need to. And according to Sean and Michael Winkler, if you use the air core pot on induction, it'll actually burst and pieces of metal will fly everywhere. So we figured we'd avoid that one for this experiment.
Cool. So some of our results. We found that insulated cookware greatly decreases energy usage. As you can see here, our slow cooker, pressure cooker, and insulated pot all have much lower energy uses per cup than our electric and induction stove. Also note that we found that the size of the pressure cooker, like the extra volume inside of it, did not drastically make a difference in our results. We're always generally in the same range. But what's really interesting here is that we were able to bring down the energy usage of our electric cooktop by 38% by just using our insulated pot, which is really cool because it's even lower than what we would use than our induction stovetop numbers came out to be. Next slide. So here we have time of energy usage by cookware. Just note that this is the time that the cookware is actually drawing energy. We need to know this because the insulated pot is a little different because it actually does take like an hour and a half to 2 hours to cook the garbanzo beans completely, but it uses energy in a different way than, say, the slow cooker. We see the slow cooker takes a really long time, and that's because it's drawing little bits of energy throughout while it's cooking. But the insulated pot just takes all that heat initially and then holds on to it. But if you remember from the previous slide, the slow cooker actually does have a lower amount of energy use than our insulated pot. And we also saw that our pressure cookers is still the fastest in cooking time and had the least amount of energy usage. So to our practicality. So we did not take a poll from the general public. These smiley faces are relative. These are assumptions based off of our own experiences, and the ratings are just relative to the other products. It was really cool. We got to experience using all of these. So this is just based off of what how we felt about them. So first, let's look at our electric resistance. This was our baseline for what we're rating these off of. You see that time is we have a frowny face for energy usage was not good, but our behavior and skill change is a big green smiley face because you don't have to change the way you're cooking at all. If we look over our induction range, great on time, good on energy usage, it's just a half face because our pressure cookers turned out to be so great in energy usage. And behavior and skill is still a smiley face because you don't actually have to change the way you cook that much. We do have a frowny face in our cost just because you do have to have a whole new stovetop, and you have to replace your pots and pans with pots and pans that are able to work on an induction range, which is not everything. And our pressure cookers, we are great on time, great on energy usage, but this smiley face is or this frowny face is a big one. So behavior and skill change. Imagine coming into a apartment complex and there's no stovetop, just a pressure cooker. That would be crazy and totally impractical, right? There's no way you could always cook off of a pressure cooker. So this is why our ideal kitchen is actually to have our induction countertop range and a pressure cooker. One more thing over on about the insulated pot. So we have behavior and skill change is kind of iffy because there's no guarantee that someone's actually going to be using this insulated pot on the electric cooktop. And notice that this is a pot. We don't have an insulated pan as well. So the great thing with induction range is going to work on pots, pans, and everything. With our insulated pot, you're still going to be using electric resistance with your pan and not getting that benefit. So next we have our ideal kitchen. This is actually in my kitchen. So we have our induction range with our compatible pots, and we have our pressure cooker right behind it. So we use a pressure cooker as much as possible and use our stovetop when necessary.
So in conclusion, we found that insulation is the best way to minimize our plug load and energy demand within the kitchen. We found this through the pressure cooker just had a really incredible amount of low energy needed to cook the food, and the air core insulated pot was able to minimize the most demanding product of our selection by more than a third. So, you know, it's really key to be able to control this heat into cooking the food rather than going out and being lost somewhere. And yeah, it's really good to also, in addition to having the induction cooktop for, you know, the minor things, to just really focus on insulation. We would like to thank you all for listening to us, and if you have any questions, please just let us know. Thanks a lot, guys.
Thank you.
Hey, good job. It's worth pointing out that the dramatic reduction in energy consumption by going to insulated cookware also reduces the air conditioning load in the kitchen. You know, you showed at least 1/3 as much energy, right, with pressure cookers and with slow cookers, like just using those plug-in devices. That was at least 1/3 as much energy as your stovetop to get the same job done, which means it's 1/3 as much air conditioning load in the kitchen, which is often a really hot place on a hot sunny day. And if you're trying to also cook food, I know that people make choices about cooking food at different times of the day because their kitchen gets too hot, for instance. It can just be miserable. So I just want to bring that forward for people also. So because we're going to move over quickly here to Michael Hicks, could you guys respond to comments and questions over in the chat on the side? There's a whole bunch of people like, yay.
Yep, we'll do.
Thank you. Excellent job. Super cool research.